Algebra Unit 10, Lesson 1, Notes 1, Graphing Parabolas over an Interval. Quadratic functions are nonlinear and can be written in the form f of x equals ax squared plus bx plus c, where a, b, and c are numbers, rational numbers. A cannot equal 0 either. You need that x squared term. This form is also called the standard form of a quadratic function. The shape of a quadratic function is called a parabola. A parabola is symmetric about a central line called the axis of symmetry. The axis of symmetry simply intersects the parabola at only one point called the vertex. The vertex is also known as the turning point. Roots are the solution to a quadratic function and indicates where the parabola crosses the x-axis. Okay, so there was a lot of vocabulary in there. Let's look at our key concept underneath, quadratic functions. So we have this function, f of x equals x squared. That's the parent function. We'll learn more about that a little bit later. Standard form, as we discussed above, ax squared plus bx equals c. It's called a parabola. That's the shape. It's not a line. It's called a parabola. This is your formula to find the axis of symmetry. X equals negative b over 2a, and your y-intercept is your c value. But let's take a look over here. We've got this blue shape here. This is the parabola. The axis of symmetry is this dotted red line. So basically, I can fold this parabola in half on this line, and it would be symmetric. It would be the same on both sides. That's why it's called the axis of symmetry. The point at which the axis of symmetry touches your parabola is called the vertex. If you notice, we also call it the turning point because let's say I'm decreasing. I'm going from left to right. I'm decreasing. All of a sudden, I hit this axis of symmetry. Now I'm increasing. So it's a turning point. First I was decreasing, now I'm increasing. So we also call that the turning point. The roots are a solution to a quadratic function. It indicates where it crosses the x-axis. So this number right here, which I could approximate as negative 1, 2, 3, close to negative 3.5, not quite. So that is a root, approximately negative 3.5, and approximately negative 1/2. Okay, again, that's just an approximation. So those are called roots. Again, axis of symmetry cuts the parabola in half, so it's symmetric. The vertex is the lowest or highest point of a parabola, also the turning point, and the roots are where the parabola crosses the x-axis. When graphing any function, there can be limitations as to which values to graph. These limits are referred to as intervals. Graph f of x equals x squared minus 2x minus 3 over the interval negative 2 is less than or equal to x is less than or equal to 4. I would also say x is between negative 2 and 4, inclusive, meaning we include the negative 2 and 4. I know that because of these lines underneath, the equal to portion. Then identify the vertex, axis of symmetry, and roots. So what I need you to do is I need you to go on your graphing calculator. I need you to hit the y equals button up towards the top under your screen. It'll bring you to this screen right here, okay? I want you to type in x squared minus 2x minus 3 in your y1. If there's something there, hit the clear button and it should go away. Make sure all of these are clear. Remember, your x is towards the top of your calculator as well. Go ahead and plug that in. Then what I want you to do is hit the second function. It's the colored key on the left. And then I want you to hit the graph button on the top right. And above that in blue, it says table. That's why we hit the second key. That brings you to your table. This gives you your table of values. So basically, if you were to plug in negative 2 into this equation, you would get 5. It does it for you. So what we're going to do, if you don't see -2 on your x values, okay, highlight the top number and just keep hitting up on your calculator until you see -2. I'm concerned with the values between -2 and +4. Those are the only values I'm going to graph. Okay, so let's go to our graph. We're going to show our work. We're going to just copy down this portion of the table only. So let's go ahead and do that. Okay, it's no longer on my screen, but it should still be on your calculator. To show our work here, we're going to draw a table. We're going to go from -2 to +4. You could write a little bit smaller on your paper. You don't have to use the whole space. When we have -2, we get 5, then 0, -3, -4, -3, 0, and 5. And I want you to notice a pattern here. Notice how it's got this rainbow effect. Okay, where -4 is your lowest value in this case. Okay, so 5, 0, -3, -4. -3, 0, 5. Okay, plot the values. Okay, we have -2, 5. Oops, that's a little large. Let's undo that. Okay, -2, 5, 1, 2, 3, 4, 5. We have -1, 0, 0, -3, 1, -4, 2, -3, 3, 0, 4, 5. Now, we have an interval, which means I should not have arrows. I need to start at this point, draw a curved line, not a V, a curved line, and end at this point. Do not go past either of these points, and do not draw arrows. And try to make it as curved as you can. Okay, I'm going to try and redraw that. There we go, that's a little better. Okay, that's how we graph it. To identify the vertex, axis of symmetry, and roots, we can actually do this by looking at our table or our graph. But let's look at our graph first. The vertex is the turning point. Here is where it turns. So this ordered pair is the vertex. That ordered pair is 1, -4. The axis of symmetry goes through that turning point. Draw it with a dotted line, and that one does get arrows on it. We need the equation of that line. It cuts through the x-axis, and it's a vertical line, so it's definitely x equals. And it cuts through at the x value 1, so x equals 1. And the roots are where it crosses the x-axis. So our roots, you could write them two ways. You could write them as x equals, the x values are -1 and +3. Or you could write them as ordered pairs, so -1, 0 and 3, 0. These points are also in your table. They won't always be in your table, so be careful. Our vertex, our turning point, that, look at the y values, that's where it turned. Our axis of symmetry is the x value of the turning point, not a coincidence. And your roots are where your y value is 0, and your y values are 0 at -1 and 3. So you could either look at the table or the graph to figure this out. In quadratics of the form y equals ax squared plus bx plus c, if the a value is greater than 0, meaning the a value is positive, the parabola opens up, and the vertex will be a minimum value. And let's draw a little picture. Okay, something along those lines. If a is less than 0, meaning negative, the parabola opens down, and the vertex will be a maximum. And there's a little diagram. Graph each quadratic function over the given interval, and then identify the roots, vertex, axis of symmetry, and any maximum or minimum value. So what I want you to realize is your vertex is going to be the maximum or minimum value. It depends on whether or not your parabola opens up or opens down. Okay, so you just have to identify the vertex as a max or min. For example, letter B. If we were to plug this into our graphing calculator, go to your y equals, clear out your previous function. We have negative x squared plus 6x minus 7. Go ahead and go to your table. This time we are looking at x values from 0 to positive 6. So 0, 1, 2, 3, 4, 5, and 6. Your values are negative 7, negative 2, 1, 2, 1, negative 2, negative 7. Now, I'm not going to tell you necessarily if it opens up or opens down. You're going to figure that out on your own. I'm not going to graph it with you. Remember, this part is your vertex, your turning point. So when you graph it, you need to tell me if that's a maximum or a minimum. Again, refer up here. If it opens up like this, that turning point, that vertex is a minimum. If it opens down, that turning point is a maximum. Go ahead and try letter B and C on your own.